morning students, welcome back to science class of 7th. Children, in our previous video, we had covered the topic the heating effect of the current. Okay, now we will be proceeding towards our next topic, that is the cause of excessive flow of current. What are the causes for the excessive flow of current? So there are two causes. First one is short circuit and the second one is overloading, right? So what happens in short circuit? Okay, the touching of live wire and neutral wire directly is known as short circuit. So in household wiring, there are two types of insulated wires. They are, the first one is the live wire and the second one is the neutral wire. Okay, so sometimes what happens when the live wire and the neutral wire come in contact with each other, when they touch each other, then there is excessive flow of current resulting to the heating of the wire, causing the short circuit. Okay, and sometimes what happens if the wire is torn, its insulator is removed, its covering is removed, then also when the two wires touch each other, there is excessive flow of current through the wire and the short circuit can happen, resulting in the fire. Okay, so this is called as short circuit when the live wire comes in contact with the neutral wire, resulting in the damage of the electrical wiring of the house, shop or any particular area. Okay, now the second one is overloading. Okay, overloading means there is more excessive loading, right? When too many electrical appliances are connected to a single socket, they draw an extremely large current from the household circuit known as overloading. Okay, so what happens in our house, we use lot of electrical gadgets, appliances like fridge, TV, cooler, AC, mixer grinder and many other things. So what happens when a lot of electrical appliances are used from a single socket? Okay, so what happens when too many electrical appliances are connected to a single socket, then what happens? There is excessive flow of current resulting in the heating of the wire, which shows that it is overloaded. Okay, then the current is overloaded, then what happens? The household circuit breaks down, it burns, resulting in the damage of the appliances. So many personal appliances like fridge, TV, etc., they have their own fuse. Okay, so when the excessive flow of current is there, automatically their fuse melts, preventing the damage of the particular electrical appliance. Okay, now fuses used in electrical appliances. Now what is fuse? Why it is used in electrical appliances? Yes, fuses are put on the main switchboard in our house or in our shop to protect the whole wiring and individual domestic appliances for damage. You must have seen fuse, means it is made up of porcelain clay and there is one thin connecting wire. Okay, so it is there to protect the electrical appliances from being damaged. Okay, so what happens in this case when excessive flow of current is there, जब current ज़्यादा exceed हो जाता है to its limit, then automatically the fuse wire melts, breaking of the circuit, and when there is no electrical supply, then the electrical gadgets or appliances are protected from damage. Okay, so as you can see in the figure, children, this is a fuse, particular fuse. It is having a fuse wire, then metal cap, two metal cap is there in which we insert, like it's like a socket. Now we put it inside. So there is one fuse wire, then at the side metal cap is there and there is one glass tube. As you can see, this fuse is used in electrical appliance, and here you can see broken fuse wire. When there is excessive flow of current, then the fuse wire melts and the electricity breaks off. Okay, so this is blown up fuse. When the fuse wire is broken, that means it is blown off because of the excessive flow of current. MCB. Now what is MCB? Uses of MCB in place of fuse. The full form of MCB is miniature circuit breaker. What do you mean by the word miniature? Miniature means small. So we can say it is a small circuit breaker. When there is excessive flow of current, then automatically it gets off. Okay, so MCB stands for miniature circuit breaker. MCB works on the magnetic effect of the current. Previously we have studied that there are three effects of the current. The first one is heating effect, the second one is magnetic effect, and the third one is chemical effect. But in this chapter we are going to study about only the heating effect and the magnetic effect, and the chemical effect we will be studying in the higher classes. Okay, so MCB works on the magnetic effect of the current instead of the heating effect of the current. Okay, so what happens? It is a special kind of electrical switch which automatically turns off when the current in the circuit becomes too large and cuts off the electric supply. So we can say MCB is a type of switch. It's a special switch which automatically gets off when there is excessive flow of current in the circuit, thus preventing the damage of the electrical appliances. Okay, it is totally different from the normal fuse. In normal fuse, what happens if there is a short circuit or the excessive flow of the current? The fuse wire melts and we have to replace it. But in the MCB, we don't have to replace it again and again. In this, what happens? When the fault in the circuit is corrected, then when the switch is on, again it starts working. Nowadays everybody is using MCB instead of this normal fuse, and we should use good ISI mark MCB, that is miniature circuit breaker. Okay, so it is an alternative of fuse, normal fuse that we can use nowadays. Okay, we don't have to replace it again and again. The main advantage is that it is for only once, while in the normal fuse we have to replace it again and again when there is any short circuit or overloading of the current. Okay, now magnetic effect of the electric current. So we have studied there are three effects of the current. Heating effect we have completed. Now the second one is the magnetic effect of the current. Okay, so what happens in the magnetic effect of the current? When the electric current passes through a wire, the current carrying wire behaves like a magnet. This is called the magnetic effect of the current. So in this, what happens? When a current is passed through any wire, then what happens? When wire gets heated, it behaves like a magnet, and this is called as the magnetic effect of the current. Okay, so the magnetic effect of the current was discovered by a scientist named as Hans Christian Ørsted. So he performed an experiment. What happened in this means, when the current was passing through a wire, then he brought a magnetic compass near the current passing wire. Then what he found, that the wire behaved like a magnet. Okay, and it attracted the needle of the compass, and we know the magnet will always rest in north-south direction. A magnet has two poles, north and south direction. So from this he concluded that a wire carrying current behaves like a magnet, and this is called as the magnetic effect of the current. Okay, so this was discovered by the scientist named as Hans Christian Ørsted, and he found that current carrying wire behaves like a magnet. Means we know a magnet has two poles, north and south. So children, that's all for today. In today's topic we have covered the short circuit, overloading and the magnetic effect of the current, and I hope that everybody have understood it very well. So children, note down today's homework. Question number 1 is, what are the two causes of large current flow? Right? Then the second one is, what do you mean by this short circuit? Then question number 3 is, what is overloading? Question number 4 is, what does MCB stands for? And question number 5 is, what do you mean by the term magnetic effect of the current? Okay children, so please go through the chapter, underline the important points, learn all the key terms, definitions of the chapter, and do these question answers in your homework copy in a neat and clean handwriting. In our next live class, we will be discussing about the electromagnets. So be prepared for your topic. So that's all for today. Thank you class. Take care of yourself.